Yeah, we are back with Matthias and the enterprise side of life of Power BI. And today you have a new release or a sneak preview to a new release, I think.
Yeah, absolutely. Great to be back. Thanks for hosting me again. And over the weekend, a new pbi-tools release went out. I'm almost ready writing up a blog post with all the changes. And I thought we use today's session to do a run through of what's new. There's some stuff in there which I'm really excited about. So hopefully we can sort of keep it contained time-wise, but yeah, definitely very keen to share. Let me share my screen.
Yeah, the stage is yours. I'm excited. I heard about dataset deployments, a new version of this. And yeah, just waiting for your screen and then the stage is yours.
Yeah, sorry, I always have that problem where the share button does not appear because my window is too small. Here we go. I've got it now. All right. Okay, so you should see my website. So that's the blog. I don't really have much in here historically, but I'm always, planning to get better moving forward. So this is a brand new blog post, dataset deployments, second preview. The first preview was announced end of May. That's actually when dataset deployments came into pbi-tools for the very first time. Prior to that, we only had report deployments. There's so much to be done with respect to dataset deployments. I'm basically running through sort of several iterations here to get this fully completed. In fact, looking at the recent article, if you scroll all the way to the bottom, there's a section, What's Next? Where I've listed out the various dataset deployment related features already in place, those ones here, as well as what's coming. Now, it looks like only a small subset of what's needed is actually done. However, that's not quite accurate. Those 5 items up here, they are by far the most significant ones in terms of work on my end, as well as features. So all the ones down here are basically long tail, but ultimately they're necessary to get full automation. So to give one example, right now, you wouldn't be able to set credentials or link a data set to a gateway as part of the deployment. Just haven't committed that yet. So that's listed down here, and it's ultimately necessary for us to actually get full automation. So right now, once you've created a data set for the first time, you'd have to navigate into Power BI service, take ownership, and then set credentials. And from that point on, everything else would be automated. I want to get to a point where that manual step isn't even necessary, where everything is completely automated. So that's pretty much the idea of, first of all, why that's yet another preview. There are still some features missing, but also to give everyone an idea of where we're at. But what's available now is something I'm mega excited about, as I said. Basically, if we go in here, where we've got a live demo. So this is a deployment I ran with the new features in place. And if we look into the logs here, I'm just going to scroll down. We can see this bit here from line 73. that's where the refresh portion of the deployment starts, and all of that output below is new. So what's new is what I call refresh tracing, where basically using the XML endpoint, the tool will now set a server trace, which allows us to get live and very detailed information about what's actually going on as part of the refresh. And this is emitted into the log. So you actually have it for reference, and you've got a record of that as part of your deployment pipeline. It allows, particularly for complex data sets, to actually trace in nice granularity which partitions or tables are particularly expensive in terms of refresh, where's a lot of time spent, let's say, with internal Vertipack processing, or where's a lot of time spent with regard to running SQL queries on the remote data end. So that's new, and it has two parts to it. One is the logging, basically just giving visibility. So here, for instance, we can see, if I just zoom in once more, this is Contoso. So we've got a sales table with 100,000 rows, as you can see. And when it comes to importing data as part of a refresh, the default log cadence is every 10,000 rows. So we can see that very nicely. There's an entry for 20,000, 30, 80, 90, 100. And then ultimately here, this is where the refresh completed. And we can see there's a different type of event. So previously we had current events. Now we've got an end event. And that one literally says finish reading data for the sales table and how many rows we've got here. And so that's the type of data we're getting here. And because those end events basically give us a very nice summary of what actually happened for every single partition, how many rows were read, but also how long the refresh took. The second part of what pbi-tools does now is to actually create a summary table. Unfortunately, it's not very nicely formatted in GitHub here, but we'll see a nicer version of that in a second. And that is one which basically gives you a very nice report. Particularly, it's also one that you could actually run some analysis on to get some trends. If you've got a production data set that is in place, for months or years, you could actually export that data to see what are your refresh stats and are there certain patterns here? What's the trend? Are certain partitions growing exponentially or so, right? So all of that is possible. And in addition to just having this output here, that refresh summary is also exported to a CSV file. And we can see that here very nicely. If I then go back into my pipeline run, and again, I'm always using GitHub as an example, but what I'm showing basically works in any of the CI/CD tools in the exact same way. So I've actually enabled CI/CD artifacts here. So if I click on this, I'm actually getting a zip file which contains that CSV file, allowing me to then look into the stats. I've already opened that file. I've got Excel here, and that's basically what it looks like. Let me just, how can I collapse that? Here we go. I've got row counts. I've got duration and CPU time metrics for specific partitions in my model. I can also see that there are different types of events actually distinguished here. So if you take this export and pivot it like so, you actually end up getting a very nice and very useful view. So what have I done? So I basically pivoted by table partition here, and then I put the event types here, and the various figures here are all milliseconds. So we can see that the customer table, for instance, spent just over half a second to run the external data query. It took 0.7 seconds to process things inside WordPack. And the overall duration of the refresh for this entire table was 1.4 seconds. We can see that here. We can also see very easily that the sales table, well, not surprisingly, obviously, is the biggest one. That has 100,000 records, and that was still relatively fast with respect to the execute SQL event, as you can see here. But reading data and processing took substantially longer here. So the total for that is 3.5 seconds. So that's something we can grab from that information very nicely. And then over here, I pivoted the same data, but this time on row count, just so we can see how many rows were actually read for individual tables. So that's the output. That's what's being produced, and I am excited for two reasons. First of all, there's incredibly valuable information in here, and at work, I've actually used this approach already to check out various of our production data sets, and have found lots of interesting insights and unexpected intel, basically, where particular tables that I never really considered to be particularly heavyweight, for instance, actually took up a significant proportion of an overall refresh. The second part is that whilst all of that information is freely available, as long as you've got an XMLA endpoint, currently it's very hard to actually get there. People usually fall back to SQL Profiler, which is a SQL Server management tool, which gives you access to all of that information, but from my point of view, it's really sort of heavyweight and hard. You need the right permissions, first of all. You need to go into SQL Profile and define which events you want to listen to. You need to then start and stop a session. So you're basically collecting information for further analysis. All of that is what pbi-tools now gives you for free, and it just does it automatically, as we've seen. So let's talk about how that all works and how to enable it. I've got the Contoso deployment repo open here. That's publicly available on GitHub under pbi-tools, and I've used that same project to actually demo dataset deployment features previously. And I've basically extended the deployment manifest to add those additional features. So when it comes to refresh tracing, that sits under options refresh. If we go in here, we can see there's a new tracing section. So that's entirely new in this release. That didn't exist prior to that. And that's basically where we're defining everything that happens around tracing. So first of all, we can enable or disable tracing. Secondly, log events basically determines what happens with respect to CI/CD log outputs, and summary determines what happens with regard to the summary metrics we just looked at. So for log events, it's pretty straightforward. We basically put a filter here where was saying, what's the event category we want to capture? So I've got a wildcard here, so any category. What's the SSAS calls that the subclass? So it's basically an event type. And then what's the object type? So what I'm saying here is I only want to see tabular refresh and read data events for partitions. And I want to ignore everything else. If you don't put any filters in here, you're going to be overrun and you're going to get extremely granular events. So it's definitely useful thinking about what you want to see. For summary, there's a slightly different filter pattern. We're basically saying which object types do we want to generate summaries for. So I've only done it at a partition level here, which I think is probably the most useful for production purposes. And then what type of events do I want to capture? And those are the 4 we already saw in my favorite table earlier. It's basically execute SQL happens first. This is what happens sort of externally with respect to your data source. Then read data kicks in, which is basically loading data into the engine. Then process happens, and tabular refresh is some sort of umbrella event, which basically captures the entire duration of all the various sub-events. So with those settings and with the out path provided as a CSV file path, we then get exactly what we just looked at. Console is a true false property. So if I set this, if I enable this, I'm going to get the output for that printed to the console. So I'm just going to run that locally, so we can also get the live effect and get an idea of what that looks like in real time. And because it's a relatively small data set, the whole process isn't going to take very long. So there we go. So this is refresh started. Events come through in real time as it happens. And now we can also see the summary table nicely formatted. And even this particular version of it is actually very neat as a report. And again, we can see how the settings from here are reflected down here, right? So because I filtered on partition, I only get partition entries here. If I put table there or measure or anything else, those would also be emitted. I filtered on those 4 subclasses, which then makes those appear here. And over here, in terms of the 3 metrics, row count, duration, CPU time, that's basically hard-coded. That's what you're always going to get. And we can also see time intelligence, as an example, is actually a calculation group. So that one doesn't read any external data, which is why we do not have an execute SQL event here, right? Because there is basically nothing coming from outside. The same happens for any calculated tables. They would only have read data, process, and tabular refresh, but not execute SQL. I think there is one here. Yeah, metric, actually. That one is actually, I think that one is also a calculation group. But yeah, the same thing would apply for calculated tables. And yeah, that's, let me see. I think that's all there is in terms of introducing that. I mentioned the blog post earlier. So just going back to that, I've done a pretty extensive write-up here of this particular feature. So it's all happening under refresh tracing. So I'm talking a little bit about the motivation and sort of what problem we're addressing here. Then I'm giving a complete pbi-tools deployment manifest in order to then explain the various tracing related settings. I'm talking about what types of event categories are exported and where to find further reference for those. And also how the log event filter works and how you can actually use wildcards in a very flexible way. And then we've got an example for the output. We've got an example for the CSV file. And we have an example for that pivot table we were just looking at. And at the end, I collected a few references, blog posts and book articles, which are available, also related to tracing and actually collecting those exact stats. Another feature that's new, so I'm just going back to the top here. There are basically 4 big new features. Another feature is the ability to deploy what some people call thick reports. And we can actually demonstrate that in the exact same project. So what I've got here is Contoso sales, which is basically a Power BI desktop data set that, well, as all Power BI desktop data sets, also have a report associated with them, right? So we can see there are actually 6 report pages in here. And before this release, the dataset deployment mode would completely have discarded the report and would basically only have worried about the model and would have sent the model over to an XML endpoint and then done a refresh and all of that. What's now new, and it's incredibly simple to enable, is that when your sources happen to have an embedded report, you can actually deploy the report alongside your data set. And what's happening is that the report will be converted to a thin report automatically. So this is also something which, where you're getting some magic for pbi-tools. Lots of people, in the wild struggle with splitting thick reports into separate model and thin reports. So this is precisely what is now happening. I've got my sources from a single PBIX file containing report and model, as we can see. But the deployment will split them. We'll deploy the dataset first, because obviously we need to have the dataset reference, and it will then generate a live dataset connection, inject that into the report sources, and deploy the report as a thin report only. And that is enabled with a single line, which is that one here. So under options and dataset, if you set deploy embedded report to true, it will do that for you fully automatically. And with no other settings, it will basically take the name from the project and will use that as the report name, and it will take the workspace from the data set and will put the report into the same workspace. However, that can be configured. So let me just show what that looks like. Development, we have datasets dev as our workspace, and then we've got Contoso sales dev as our dataset display name. That means the report will go exactly there as well. So if I run this again, here we go. So I'm not specifying an environment here. In that case, it always defaults to development. Development is a default environment. That's the one you don't have to specify explicitly. So okay, basically this is where the model deployment is completed. We then get some Power BI dataset details. The ID and who owns the dataset and all of that. And now, immediately afterwards, the embedded report deployment actually kicks off. And it basically does pbi-tools compile, but what's different is that it's now basically generating behind the scenes a connections file, which has a connection to that exact same data set. And we can see it then gets imported as Contoso sales dev. And if I go into that workspace, data sets dev, here we go. We can see it's that one, because this one actually has a slightly different name. And if I look into lineage view, I can see this data set. This report is linked to that data set, and opening it up, we can see well, actually, if I go into edit mode, I can prove that this is exactly what's happened here. So if I put if I take the fields from the info table and display that, sorry, like so, we can see that this is actually what's come from my local machine just now, because obviously my machine doesn't have any GitHub environment variables, which is why we didn't actually get those variables injected here, right? So this is how we can tell very nicely. Plus, obviously, this is the time from just now. So yeah, that's also new, and it helps where you have self-contained projects, where it's literally report and data set and not much else. We do have a few of those at work as well, and I think that's probably quite common. And it also helps where, again, something we do quite a lot, where you actually use the embedded report just for development purposes, so that basically your developers share that embedded report internally in order to test and demonstrate any model changes right there. So that's then not meant to be used and distributed to any users, but it's still very useful maintaining that report. And in that case, I would not deploy it into production, but I would deploy it into the dev environment. And achieving that is also in the box already. So basically, with this setting, if I were to put that down here, and if I set skip true and skip true here, what that means is for the embedded report, it's going to be skipped for those two environments. It's not going to be deployed. It will only get deployed into development. Yeah, so that's new. And then thirdly, and again, we can actually stay here. There was quite a lot of change with respect to parameters. And in fact, we can see two of those changes here. So first of all, you can now set a parameter to null. Previously, only string values were supported, which was quite restrictive. And secondly, you can actually refer to internal parameters inside your explicitly declared parameters. So those two parameter labels, environment and pbi-tools version, they are generated as part of the pbi-tools process. They are not environment variables. They don't sit on my machine, nor would they be defined in my CI/CD host. So that's new. And as you can see, there's a slightly different syntax. So for environment variables, we're using percentage signs, and for referencing other parameters, we're using double curly braces. And yeah, so the biggest change here is not very well visible, though, because not only can you specify null, you can actually specify any Power Query supported type. So if we're looking into our queries here, we have a date type parameter. That's a pattern I use quite frequently in order to take advantage of query folding, where in development environments we're putting additional filters into the data set, so that for developer a full data refresh is actually much faster than a production data refresh. That means the date filter itself will basically be in our sources. That will sit in the repository, so that anyone cloning the repo and compiling that into a new file will basically get those parameters like that. But obviously for production deployment, we need to reset that, right? And so the Power Query syntax for that would be to actually put the null keyword in here. Previously, that wouldn't have been possible, because previously pbi-tools would always have emitted a string enclosed in double quotes. So now that's possible. But what's also possible, so if I go back here, I could actually use a Power Query expression like this. And if I put that here, and I don't know, maybe set this to 2007, because that expression starts with a hash character, it's automatically recognized as an expression rather than a string, and the replacement will then put it in here verbatim without actually enclosing it in quotes. So and the same applies to Booleans and numbers. So strings, nulls, dates, timestamps, date times, Booleans, numbers, they can all be used in parameters and can basically be injected at deployment time. The one significant change, which I haven't deployed yet or haven't got in a release yet, but it's coming very soon, is to the ability to define parameters within specific environments, because that's actually what you need in the real world. In production or UAT or development, you oftentimes want to set parameters differently. For instance, connecting to a different SQL server or actually using different filter expressions. That's not currently possible, but it's coming very soon. If anything, because I heavily need it. Yeah, that's pretty much a quick run through of what's new.
Yeah, lots of stuff. So for me, this all embedded report thing is is a use case almost for every project, I think, because it's quite common for me still when I need the data and the report in the same file, and it's much more comfortable to develop because you know where the data is coming from. You can change some things in Power Query, and at the end it was quite Power BI tools was still the best way to split the data set and the report, and now it seems to be much more comfortable with the it's done automatically when you deploy. It's awesome. And also the parameter thing, it's quite cool. I also use such parameters in development, but I use them in Power BI Desktop. And here, this is more professional when you need the version control in the deployment. Another question is, so why do you not use the more obvious sources of performance tracing like DEX Studio or the inbuilt performance analyzer and all this stuff? You just mentioned
Mm.
the SQL analyzer, but there are, I think, much easier ways
Mm.
to do this.
Mm-hmm. I'm specifically interested in refresh performance. Actually, what happens as part of a data set refresh, right? And that's not what DAX Studio or any other existing tool does for you, right? What they look at is what's going on inside the Vertipack engine when you execute a query, which is extremely useful, but it's a different concern, right? The
Okay.
question here is, I've got some data sets that, take over half an hour to refresh. And other people might have data sets that take hours, right? Who knows? If you want to get some data to figure out, well, what actually happens during that time and what can you possibly do to optimize it, that's what I'm talking about here, right? And that's why you basically need to run a trace during the refresh and as it happens.
Okay. It's because SQL was only part of it, but getting data is also like the getting data from the external source and not Power Query.
Yeah, so
Okay.
execute SQL is a bit of a misnomer here. It probably just shows the heritage of SSAS, but what it really means is running the remote data fetch command. Whatever your data source may be, right? So, like the example I've got here, it actually has data coming from CSV files hosted on a HTTP endpoint, right? There's no SQL at all. But nonetheless, because it's the external data access, it's still being logged as execute SQL.
Okay. Yeah. Okay. Quite well. And no other questions. So yeah, thanks a lot for the sneak preview. I'm really looking forward to some features there. And yeah, see you again next time with Power BI tools. You're developing quite fast. Maybe one last question from myself, as you have such a big backlog and this is only one feature. Are you still developing this alone, or do you have a team only for Power BI tools in the meantime?
No, I wish. No, I don't. It's all me, and usually weekends and evenings. So yeah,
Oh,
it's it's a big passion. Otherwise, it wouldn't be possible. Let's put it that way.
wow. Much respect for this, and yeah, a good evening, and see you next time, Matthias.
Absolutely, looking forward to it. Thanks very much.